Hey everyone, and welcome to The Explainer. So glad you're here. Today, we're diving into something really fascinating, modern architecture and how it manages to merge jaw-dropping aesthetics with, honestly, incredible energy efficiency. For decades, right, building a home felt like this constant game of compromises. But what if I told you the materials and designs we have right now have completely rewritten the rules? We're going to break down everything from the absolute macro, like where you literally place the house, down to the micro, the very materials holding your glass in place. Let's get into it.
And that brings us to the big one, the massive question architects and homeowners have been wrestling with for years. Do we actually have to choose between a gorgeous home and an energy-efficient one? Historically, we just assumed that a beautiful building with those massive, sweeping windows was destined to have terrible insulation. You'd be freezing in the winter and roasting in the summer. But the fix for this is an amazing macro to micro journey. We're not just looking at the glass itself, we're looking at how to design with nature instead of constantly fighting against it.
Okay, Section 1. Harnessing passive solar power.
So, long before we even think about picking out window frames, we have to talk about where the house actually sits. The golden rule of passive solar design is all about orientation. To get the absolute maximum free solar heat during the winter, you really want the home's longest wall facing within 15 degrees of true south. But hey, here's some surprisingly great news. Even if you've got a tricky plot of land that forces you to pivot, say up to 30 degrees off true south, you are still going to capture about 85 to 90% of that optimal winter heat. Pretty amazing, right?
Now, if we really want to optimize this, balancing your glass with what we call thermal mass requires some exact math. You can kind of think of thermal mass, like thick masonry walls, as a giant natural battery for your house. So if your south-facing glass takes up to 7% of your floor area, boom, you have a sun-tempered home. No extra thermal mass needed. But if you push that up to 12% for a direct gain system, well, for every extra square foot of glass, you're going to need 3 to 6 square feet of 4-inch thick masonry. Why? Because it absorbs the sun's heat all day and then slowly releases it back into your living room at night when it gets chilled. And check this out. Notice how east and west glazing is kept strictly under 5%. That's absolutely crucial so your home doesn't turn into a total oven in the summer. And because all these windows are doing completely different jobs, they actually need different specs. Your south-facing glass is literally acting as a natural heater, so it needs a high solar heat gain coefficient, meaning, it's built to let that solar heat in, paired with a low U factor, which just means it has top-notch insulation to trap the heat inside. On the flip side, those east and west windows, they need a much lower solar heat gain coefficient. You got to block out that super intense direct summer glare.
So how do you control all that light? Well, architects use pure geometry to size window overhangs, which are typically around 2 feet wide. Since the sun is way higher in the sky during summer and much lower in the winter, you can literally map it out step by step. You're basically drawing an invisible line that blocks the harsh summer rays while perfectly inviting that low, cozy winter light right under the overhang and into the room. It's just this incredibly elegant, permanent fix for temperature control.
All right, moving on to Section 2, the steel window revival.
So let's zoom in a bit from the macro siding of the house and look at the actual materials holding our glass. For the longest time, traditional hot-rolled steel frames were kind of this endangered architectural species. I mean, they offered these gorgeous, ultra-thin, minimalist lines that chunky PVC or wood just literally can't match. But historically, they were basically giant energy leaks. Enter the modern polyurethane thermal break. It completely saves this elegant look. By joining cold-formed steel with cast-in polyurethane, we create a solid thermal barrier. You get to keep those beautiful, historically accurate thin sightlines, but now they pack state-of-the-art insulation. Best of both worlds, really.
And the customization you can do now is spectacular. These resilient materials let us maintain a building's unique vibe while easily crushing all those strict new thermal regulations. You can go with Corten steel for this wonderfully refined, rusty look, or maybe stainless steel if you want absolute maximum strength and longevity. There's even architectural bronze. That one's absolutely perfect for high-end restoration work on heritage buildings. And when you coat them with highly durable polyurethane paints, these frames are literally designed to last lifetimes.
Which brings us to Section 3, the concealed window trend.
Zooming in even further to the absolute micro level, we find this stunning, almost futuristic detail taking the architectural world by storm. By definition, a concealed window is an innovative design where the frame is hidden completely within the wall or structural opening. So when you look at the window, whether you're inside or outside, you don't see any thick, distracting borders. Only the glass is prominently visible. It completely shifts your visual focus straight to the beautiful outdoors.
And honestly, it is so easy to see why developers and homeowners are just eating this up. By removing that visible frame, you improve light flow, meaning way more natural daylight floods your space. Plus, it creates these incredibly seamless transitions, basically blurring the line between your living room and your patio. But here is the real kicker for our overall theme today. They maintain high performance. Yep, even with hidden frames, these systems retain exceptional insulation values and use double or triple glazing to drastically cut down on outside urban noise.
Now, I do have to point out a critical detail here. This level of minimalist perfection, it definitely doesn't happen by accident. Concealed installation is incredibly complex. We're talking meticulous waterproofing and really expert structural integration to set those frames seamlessly right into the walls. You absolutely have to have highly precise installation because you cannot compromise the building's structural integrity, its ventilation, or fire safety just to get a sleek aesthetic. It has to be done right.
Okay, let's wrap this up with Section 4, Perfecting Your Window Strategy.
So, bringing this all together, passive design is truly a whole house strategy. It's not just about the windows, it's about what you actually put behind them. You want to take rooms with minimal heating and lighting needs, think garages or storage rooms, and stick them on the cooler north side of your home. And interestingly enough, you also want your kitchen on the north side. Why? Because all your cooking appliances basically act as a free space heater. As a general rule of thumb across the whole house, aiming for a 5% glazing to floor area ratio is the sweet spot. It gives you ideal natural daylighting without completely throwing off your thermal balance.
Which brings us right to our final thought-provoking question for today's explainer. When you look at your own home's windows, are they working with nature or are they working against it? Are they placed to capture the winter sun and block the summer heat? Are the frames minimizing energy loss while giving you a great view? These incredible innovations in passive design and modern materials prove that we really don't have to compromise anymore. We can have spaces that are as breathtakingly beautiful as they are energy efficient. Thank you so much for hanging out with me today, and I really hope you leave inspired to look at the walls and windows around you in a totally new light.